All right, the next section of chapter 7 is on parallel lines and proportional parts. And you'll see what that means in a minute. First thing I want to do is review what proportions even mean. So when we're talking about similar polygons, we're talking about two polygons whose sides are proportional. And what that means is that, for example, if side AB here is 12 units long, then the corresponding side, let's say, is, or if the corresponding side, let's just make it easy and say 6. Okay, the proportion between side AB and side DF is 12 over 6, which is just 2. What that means is that if these two shapes are similar, the other two pairs of corresponding sides also have to have a ratio between them of 2. So for example, if BC was 10, EF would have to be a number that when put with BC gives a ratio of 2. So in this case, it would have to be 5, right? Because then BC over EF would be 10 over 5, which when you do it on your calculator, if you can do it in your head, that's fine. 10 divided by 5 is also 2. And then lastly, DF and AC, the last two sides here, would have to have the same proportion. In other words, AC would have to be twice as long as DF. So if AC was 6, DF would have to be 3, because then AC over DF would be 6 over 3, which is 2. So when I talk about proportions, what I'm talking about are these things, right? I use proportion and ratio sort of interchangeably, which I probably shouldn't, but hopefully when I say either one of those, you'll know what I'm talking about now. So down here, what we would have is AB over DE is 2. AC over DF would also be 2. And BC over EF, we could put this over here. All three of those proportions, all three of those ratios would have to be equal to 2 if we're going to have ABC being similar to DEF. Okay, one more thing to review real quick, and that's mid-segments in a triangle. So we did this kind of towards the end of the fall. A mid-segment is just when I find the midpoint of one of my sides. So let's say AB, let's say it's 10. I find the point exactly halfway between there. In other words, I break AB up into two sides that are both 5, or two line segments that are both 5, and I make a point right there. And then I could do the same thing with AC. So let's say AC was 14 units long. I find its midpoint, which would mean separating it into two sides, or two segments that are both 7. Once I found the midpoint of two sides, I draw a straight line connecting them. That is the mid-segment. Right? So that line in the middle of the triangle is the mid-segment. A couple of things we know about a mid-segment. One is that it's parallel to the side that it doesn't touch. Right? So if I call this point E and this point F, line segment EF is parallel to this one down here, to BC, the one that it doesn't touch. Okay, I also know that EF is going to be half as long as BC. So if BC, I don't know, let's say BC is 12, EF would have to be 6. Okay, those two things are review. This is the new stuff for part 5 of chapter 7. First thing is the triangle proportionality theorem, which is just kind of a fancy way of saying that if I go inside of a triangle and draw a line that's parallel to one of the other two sides, like I've done right here. Right, so if I call this point D and this point E, I've drawn a line that's parallel to side AB. Okay, if I do that, what I've done is I've created a second triangle that's similar to the first triangle. Okay, so triangle DCE, the smaller one, is going to be similar to triangle BCA, right? As long as this red line that I've drawn is parallel to AB, I've created a similar triangle, right? And it doesn't have to be right there. I could do a parallel line anywhere inside of the triangle, parallel to any of the three sides. That's just the one I did for example here. Here's another thing though. When I draw a line like that, the two sides that line intersects with, and so in this case, that's going to be side AC and line BC. I break those two line segments up into two segments that are proportional to each other. This will be easier to see, I think, if I write it down. What I'm saying here is that when I draw a parallel line like that, I break AC up and BC up into two line segments that are proportional. And so if I was to write that out, it would be however long CE is divided by however long AE is going to be equal to however long DC is over however long BD is. So for example, let's say EC is 9 and AE is 3, then that would mean that, let's say DC is 12. Since 3 is 1/3 of 9, BD here would have to be 1/3 of 12. In other words, 4. If I want to check my work on that, again, I would just plug in numbers into this little equation I have here to make sure it works out. So CE is 9, AE is 3. That has to be equal to DC, which is 12, over BD, which is 4. 9 divided by 3 is 3. 12 divided by 4 is 3, so it checks out. Okay, so let's do a practice problem with that. That has a little bit tougher numbers so that we can see if we actually know what we're doing here. It says in triangle PQR, so that's like the big triangle here, ST is parallel to RQ. And then it says PT is 7.5, TQ is 3, and SR is 2.5. It wants us to find PS, which is that one right there. Well, since I have parallel lines in the triangle, what I know is that the relationship between PT and TQ has to be the same as the relationship between PS and SR. So I'm going to plug in the numbers that I have and then figure out what I got to do to figure out, to determine, I guess, calculate the number that I don't have yet. PT is 7.5. TQ is 3. PS is the one I don't know yet, and SR is 2.5. So we did a little bit of this, but if you forgot, that's okay. When you have a situation where you have fractions on both sides of an equation, what you want to do is what's called cross multiplying. And so I'm going to take this 2.5 and I'm going to multiply it by the numerator on the other side of the equation. So on the left, what I'm going to have is 2.5 times 7.5. That's going to be equal to 3 times x. Okay, so I take both denominators, multiply them by the numerators on the other side of the equation. So 2.5 times 7.5 is 18.75. That's equal to 3x. And from there, I would just divide both sides by 3. X is going to end up being 6.25. Next example says in triangle DEF, so that's the big one, EH is equal to 3, HF is equal to 9, DG, so there's this short side here, is 1/3 the length of GF. Okay, so it doesn't give me either number for DG or GF, but I know that DG, if I call that X, it's 1/3 as big as GF. Right, so I'm just going to call this X. If it's 1/3 as big as GF, then GF would have to be 3x, right? 3 times as big as whatever X is. Okay, so the question it's actually asking then is DE, is this line right here parallel with GH, that line right there? If those two lines are parallel, what it means is that HF over EH, okay, so HF over EH would have to have the same ratio as GF over DG. Right? So what we're really asking there is the ratio between HF and EH the same as the ratio between GF and DG? Right? Well, let's plug in what we know. HF is 9, EH is 3, GF I called 3x, and I called DG 1x. So let's just divide these out. If we get the two sides to be equal to each other, that means that DE and GH are parallel. So 9 divided by 3 is just 3. 3x divided by x would also be 3. So the two ratios are the same. So the answer to this one would be yes. DE is parallel to GH. Okay, next theorem here. This isn't a problem, this is just introducing new information. So it says that every mid-segment of a triangle is half as long as the side it's parallel to. And I sort of already reviewed that with you at the beginning, but basically what it's saying is that if I just look at RP here, RP is going to be half as long as the side it's parallel to, the side of the big, like, original triangle that it's parallel to. Well, is it parallel to AC? No, I can see that they touch. Is it parallel to AB? No, because they touch. So the side that RP is parallel to is CB here. So RP is half as long as CB. And then I can do the same thing with the other two mid-segments here. If I look at PQ, which side is PQ parallel to? It's going to be parallel to AC. So PQ is going to be half as long as AC. And then the last mid-segment here is RQ. Which side is RQ parallel to? Well, the only one left is AB. So RQ would be half as long as AB. Let's see what kind of problem that we have to do with that. All right. In the figure, XY and XZ are mid-segments of triangle RST. Okay, so triangle RST, big triangle, and it's saying that XY, this right here, is one of its mid-segments, and XZ is another of its mid-segments. Find each measure. So basically, it wants to figure out what what ST is and what XZ is. Okay. Well, if I want to know what ST is, this side right here, I have to figure out like what mid-segment is parallel to it, and that turns out to be XY. So XY is parallel to ST. In other words, XY, this mid-segment right here, parallel to ST. So I know that XY, segment XY, since it's the mid-segment, has to be half as long as ST. And I know that XY is 7. So I know that 7 is half as long as whatever ST is. If I want to figure out what this is and I want to get rid of a fraction, I multiply by its reciprocal. So the reciprocal of 1/2, its reciprocal, if I flip it over, would be 2 over 1, which is just 2. So I'm going to multiply both sides of the equation by 2. 2 times 7 is 14. The 2 and the half cancel each other out, so 14 is how long ST would have to be. Now I'll figure out how long XZ is. XZ is right here. XZ I don't know yet, so I can call it X for now. But I do know the side that it's parallel to, RT here, is 13. So XZ is going to be half as long as the side it's parallel to, which is RT. And I know that RT is 13. So XZ, half as much as 13. Half of 13 is 6.5. So segment XZ would be 6.5 units. All right, think back to Unit 2 when we had parallel lines cut by transversals. So in this picture here, these 3 lines going left and right are my parallel lines. These 2 lines that sort of go up and down are the transversals. We're not really dealing with angles when we have a situation like this, like we did in Unit 2 from the fall. What we're actually dealing with here are the line segments, the length of the line segments. And so basically what this is saying here is that if I have 3 parallel lines cut by 2 or more transversals, the segments that they create are going to be proportional. So in other words, the ratio between AB and BC is going to be the same as the ratio between EF and FG. So just to write it out for you, the ratio between BC and AB is going to be the same as the ratio between FG and EF. All right. Last example problem before you can start on the homework is a word problem, and it says frontage is the measurement of a property's boundary that runs along the side of a particular feature, such as a street, lake, ocean, or river. Find the ocean frontage for lot A to the nearest tenth of a yard. So here's the ocean frontage for lot A. That's basically saying if you own lot A, how much beach do you have? What we have to do to solve this one is see that you have 3 parallel lines here. These are basically just the lines that divide this beach up into lots owned by different people. And then you have a couple of transversals. One of them is just the shore line, basically. The other transversal is Ocean Drive here. So what I know from the last part of my notes is that the ratio between the frontage on lot A and this frontage on lot B has to be the same as the ratio between this 58-yard, piece of frontage between lot A and Ocean Drive and this 42-yard piece of frontage between lot B and Ocean Drive. In other words, the frontage of lot A over that ratio there between the ocean has to be the same as the frontage of A with Ocean Drive over the frontage of lot B with Ocean Drive. All right, the frontage of lot A with the ocean is what we want to know, so I'm just going to call that X for now. The frontage of lot B with the ocean is 60. The frontage of A with Ocean Drive is 58. And the frontage of lot B with Ocean Drive is 42. So to figure out X, we're going to do cross multiplying again. So I'm going to take 60, multiply it by 58. So on one side of the equal sign, I'm going to have 60 times 58. On the other side, I'm going to take this 42 and multiply it by X. All right, 42X then is going to be equal to whatever 60 times 58 is. 3,480. All right, and the last step is just to divide both sides by 42. And we have about 82.9. Is it feet? No, yards. And we're supposed to round to the nearest tenth of a yard, which I've already done. So the answer would be that this piece right here is about 82.9 yards.